In this video, we're going to talk about factoring trinomials. You need to know how to factor trinomials easily, quickly. If this is something you struggle with, you need to practice it a lot because you will find that throughout this course you will have trouble if you cannot properly factor trinomials. So let's look at a few of them just so we can get comfy with the format. All right. Factoring trinomials, you'll remember from Algebra 1 and 2, we would put it in this format where you usually have x times x, and then there's something that goes in here, maybe a plus 3 and a minus 2. So your answer typically looks like this. You can have more than two sets of parentheses. Sometimes you can have like a plain number in front here or variable in front. So you'd have x squared, x plus 3, x minus 2. But this is what we call factored form. Okay. So when we are factoring, you are taking a polynomial in standard form and putting it in factored form. That's our goal. All right, so just very basic from back in the day, if I want to break this up into factored form, there are a couple ways to think about it. I usually start at the front here with this x squared. What times what is going to give me x squared? Well, I only have one option there, x times x. And then I look at this 15. And I say, I need something that multiplies to 15. What times what is going to be 15? And we either have 15 and 1 or 5 and 3. And I need this, whatever pair I choose here, to add up to this middle term. So we want what multiplies to 15 and what adds to 8. All right, so the thing that adds to 8 here is this 5 and 3. So we're going to do plus 5 and plus 3. And the way we can double check to see if we have the correct middle term is we can do the outside and then the inside, the oi of the FOIL, if you will, the outside and the inside terms. Does x times 3 plus 5 times x add up to 8x? Yes, it does. All right, so this is our factored form. The x plus 5, x plus 3. The question we ask as a shortcut is what multiplies to this and adds to this, okay? It's not always that simple though, because that question won't work for this trinomial. If you say what multiplies to 20 and adds to 13, you're not going to get the right answer. You have to take into account that there's a 2x squared here. So let's start by saying, well, what multiplies to 2x squared? It has to be 2x and x. That's really our only combination. Now we need to test numbers that multiply to 20. And then when I multiply my two binomials out here, I need them to also add to 13. So if I'm thinking of things that multiply to 20, I would say 1 and 20, I'd say 2 and 10, I would say 4 and 5. And once you have a number in front of here, you're in a more of a guess and check situation because of this 2x squared. So none of these on their own are going to add to 13. I need to place them into these parentheses and then see which one works out to 13. So let's arbitrarily pick something. I'm going to pick 4 and 5. So I'm going to put 4 and 5 in here. Okay. When you're looking at the structure of this polynomial here, because this 20 is built off of multiplication, what multiplies to 20, in order to get a positive sign here, you need either both things to be positive or both things to be negative. I know that both of them are going to be positive because of that positive sign. I need them to add to a positive number. So I'm putting positive 4 and positive 5. I'm guessing. I'm not really sure right now. So the way I'm going to check it is I'm going to multiply the outside terms and the inside terms. When I do that, I get 2x times 5, which is 10x, plus 4x. And I know that 10x plus 4x does not equal 13. So that guess does not work out. So I'm going to try different numbers. I'm going to switch the 4 and the 5. What happens if I put the 5 here and the 4 here? All right. Well, now 2x times 4 is 8x, and 5 times x is 5x, and 8x plus 5x does equal 13. So by moving those guesses around, I've come up with the correct factorization. So the answer to this problem is 2x plus 5 and x plus 4, but I had to play around with it a little bit before I got there. All right. This is another one where I just have a 1 in here, so that makes it a little bit easier to think about. I need two numbers that multiply to 10 and add to -7. I know that the front is just going to be an x and an x, so I don't have a constant in front of these x's to muck up my multiplying at all. So I need two numbers that multiply to 10 and add to -7. Because this is a positive, then I know those two numbers need to be negative. They have to have the same sign in order to multiply to a positive. And then those two numbers have to be 5 and 2. So I have -5 minus 2. I double check. I get x squared minus 2x minus 5x plus 10. And when I clean all that up, I get my original trinomial back. So that is a good one. This example is a little more complicated, but it's just interesting to think about. If you say that this rectangle has these dimensions, this area and this length, and you're trying to find the width, what you're saying is x plus 4 times what gives me this area? Because area is length times width. So I'm going to say x plus 4 times what equals my area. All right, well, if this is a 4 and I need it to multiply to a 4 here, then this has to be a 1. And if this is an x and I need it to multiply to 2x squared, then this has to be a 2x. So let me double check my outside and my inside and see if that comes out right. I have 2x times x. I'm sorry, that's not it at all. I have x times 1, which is 1x, and I have 4 times 2x, which is 8x. So 1x plus 8x is 9x. So that's the correct factorization. So then the width of this must be this second factor. This is what I'm multiplying by. So the width is 2x plus 1. All right. The second part of this says if the width of the rectangle is 21 inches, what is the length of the area? And I'm sorry, what is the length and the area? So if the width is 21 inches, I know that 2x plus 1 has to equal 21. And when I solve for x, minus 1 divided by 2, I get that x is 10. So if x is 10, then the length is 10 plus 4. So the length is 14. What are we in? Inches, 14 inches. And the area, I would put 10 in for this polynomial here. So you have, I'm going to do the math out down here. I have room. 2 times 10 squared plus 9 times 10. And then I wrote over, let me do a little erasing, plus 4. Plus 4. So 10 squared is 100. So 2 times 100 is 200 plus 90 plus 4. The area is 294 inches squared. So I can use my knowledge of factors to help me solve this problem.